complex fractions. We do like fractions, so we put fractions inside your fractions. So a complex fraction is a fraction within a fraction. So that means that you either have a fraction like on the numerator, on the denominator, or you have one in both. So it's just a fraction inside a fraction. To simplify a complex fraction means to rewrite as a single fraction with no fractions in the numerator or denominator. So we just need to rewrite this as a fraction that doesn't have crazy number of fractions, okay? So the first thing we do is create a single fraction in the numerator and the denominator. Then we set it up as a division problem, and we just multiply by the reciprocal, and then we simplify, okay? This is really a lot of stuff we've already done. It's just like combining everything. So if we're given a over 2 over a squared over 4, well, the first thing we have to do is create a single fraction, but we already did it, or it was given to us that way. Then we need to write this as a division problem. So I'm just going to write a over 2 divided by a squared over 4. And then this is exactly like something we know how to do. So we can flip it. The division symbol is just a fraction with dots instead of numbers. Fun fact. Kind of cool. But now we can flip it. And that's a over 2 times 4 over a squared. And then we can just simplify this. So like the a's cancel. We're left with an a on the bottom. And then we're left with a 2 on top. So that's 2 over a. Okay. Let's do this one. So 18p over 8p minus 2, and then 4p squared over 4p minus 1. Well, we've already done the first step. It was given to us that way. So let's write it as a division problem. Then we're going to flip that. So that's 18p over 8p minus 2, and then 4p minus 1 over 4p squared. I can factor a 2 out of that 8p minus 2. Then I can just start canceling stuff. So like 2 goes into 18 9 times. Those p's will cancel, and then the 4p minus 1s cancel. So I'm just left with 9 over 4p. Cool. Okay, this one, k minus 1 over k squared minus 1 over k squared. Already have one fraction, so let's just write it as a division. So that's k minus 1 over k divided by k squared minus 1 over k squared. Flip it. That's k minus 1 over k times k squared over k squared minus 1. That k squared minus 1, that's the difference of squares. What do you call two squares that crash into each other? A rectangle. That's so stupid. Oh, sometimes I make these PowerPoints and I swear, like, why would I put that there? Just to give us a little giggle, I guess. I don't know. Okay, so that becomes k minus 1, k plus 1. And then the k minus 1s cancel, k's cancel, and I'm left with k over k plus 1. Cool? Okay, this one. So x over 3 minus 3 over x all over x minus 3 over x. So the top I need to create a single fraction. So I'm just going to combine those. So I have x over 3 minus 3 over x. Well, I can change that to be plus a negative 3x, 3 over x. Then I'm going to multiply that first fraction by x and multiply the second fraction by 3. So I end up with x squared over 3x plus negative 9 over 3x, which is x squared minus 9 over 3x. So that's what's going to replace the top there. And then I can write this as a division problem. So x squared minus 9 over 3x divided by x minus 3 over x. Flip that, and I have x squared minus 9 over 3x times x over x minus 3. And that x squared minus 9 factors to be x minus 3 and x plus 3. Now those x minus 3's cancel, those x's cancel, so I'm left with x plus 3 over 3. This one, so same thing, we need to get it to have a single fraction on the top and a single fraction on the bottom. Yep. So 1 over a squared minus 1 over b squared. Well, I can change that to negative 1 over b squared. Multiply that first fraction by b squared. Multiply the second fraction by a squared. So I'm going to be left with b squared minus a squared over b squared a squared. So that's what the top of this equals. And then for the bottom, let's just do this right now also. So 1 over b plus 1 over a. Well, I'm going to multiply that first fraction by a over a, second fraction by b over b. So I get a plus b over ab. Now I can rewrite this as a division problem. So b squared minus a squared and then b squared a squared divided by a plus b over ab. Flip that. So I have b squared minus a squared over b squared a squared times ab and a plus b. So that b squared minus a squared, that's the difference of squares. So that's going to be b minus a and b plus a. Well, b plus a and a plus b are the same thing. So those can cancel. That a will cancel with one of those, and that b will cancel with one of those. So I'm left with b minus a over ba. Cool. Okay, this one. So a squared over a plus 3 plus a squared over 5a plus 15 all over a plus 3 plus 1 over 5. So let's combine, wowza. Let's combine the top. Well, I can factor out a 5 there, and I'm left with 5 times a plus 3. So that means I just have to multiply that first fraction by 5 over 5. Which is going to end up being 6a squared over 5a plus 3. For the bottom, we can combine that. So a over a plus 3 plus 1/5. So I'm going to multiply the first one by 5 and the second one by a plus 3. So we end up getting 5a over 5 times a plus 3 plus a plus 3 over 5 times a plus 3. So that's 6a plus 3 over 5 times a plus 3. Then we divide, then we can flip that division. So I have 6a squared over 5 times a plus 3 times 5 times a plus 3 over 6a plus 3. Well, I can factor out a 3 right there, so I have 2a plus 1. Well, that 6 and that 3 can cancel, leaving us a 2 on top. The 5's can cancel, and the a plus 3's can cancel. So I'm left with 2a squared over 2a plus 1. Cool. Well, I think that's it. That was a pretty short video, so bye.